This episode is brought to you by Gnosis. Gnosis builds decentralized infrastructure for the Ethereum ecosystem. With a rich history dating back to 2015 and products like Safe, CowSwap, or Gnosis Chain, Gnosis combines needs-driven development with deep technical expertise. This year marks the launch of Gnosis Pay, the world's first decentralized payment network. With a Gnosis card, you can spend self-custody crypto at any Visa-accepting merchant around the world. If you're an individual looking to live more on-chain, or a business looking to white-label the stack, visit GnosisPay.com. There are lots of ways you can join the Gnosis journey. Drop in the Gnosis DAO governance form, become a Gnosis validator with a single GNO token and low-cost hardware, or deploy your product on the EVM-compatible and highly decentralized Gnosis chain. Get started today at gnosis.io.
Chorus1 is one of the biggest node operators globally and help you stake your tokens on 45 plus networks like Ethereum, Cosmos, Celestia, and DYDX. More than 100,000 delegators stake with Chorus1, including institutions like BitGo and Ledger. Staking with Chorus1 not only gets you the highest yields, but also the most robust security practices and infrastructure that are usually exclusive for institutions. You can stake directly to Chorus1's public node from your wallet, set up a white label node, or use the recently launched product, Opus, to stake up to 8,000 ETH in a single transaction. You can even offer high-yield staking to your own customers using their API. Your assets always remain in your custody, so you can have complete peace of mind. Start staking today at chorus.one.
Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Felix, and today I'm speaking with Itzhaki and Guy Zyskind, who are respectively the CEO and founder of Fhenix. Fhenix is an Ethereum L2 that's focusing on enabling computation over encrypted data via fully homomorphic encryption. We're going to get into what all this means in a second. But first of all, let me welcome my guest today. So welcome, Guy. And Guy.
Thanks, Felix. Thanks for inviting me.
Good to be back.
Awesome. Yeah, exactly. Yeah. Guy Z, you've been on here already. You have a big background in crypto, building like multiple of the like cutting edge projects in sort of the privacy space, at least from my perspective. So maybe we can start there and kind of start with the usual epicenter question of, how did you get into crypto and how did you end up at Fhenix now in the end?
So good to be here again. I think we've had that conversation, or at least I've said that I've told that story a few times before. I'm celebrating a decade in crypto, which is either an achievement or something to be ashamed of. I'm still not sure, and I'm still deciding. But it's been a decade. I got into crypto in around 2014, actually even 2013. Really got caught up with the technology. I was starting my master's at the same time and decided that I really wanted to focus on research and more deep diving into what we can do with blockchains beyond just Bitcoin. Ethereum was in like alpha stages back then. It was just starting out, and that was very inspiring for me. And then I landed into the problem of privacy, and specifically came out with this problem, which is today it's already like a well-established problem, but back then it was really novel. How do you do private computation on the blockchain? How do you basically do confidential smart contracts? And that was what I focused on my thesis, using secure multi-party computation technologies at the time. And that led to a project called Enigma, which eventually turned into a secret network. It had a few iterations, and secret network is today like one of the largest Cosmos chains that specifically focuses on private compute, but it uses, for the most part, trusted execution environment, which is another technology, and a few others. But then in the last couple of years, as I was going back into research mode, I kind of became convinced that FHE is the future. and basically decided to focus most of my time on that. And, that kind of turned into Fhenix in the last 6 months or so.
Right. Yeah. Awesome. We're going to get a lot into the different sort of technologies that are out there and how FHE compares to them. So I think that's kind of key to understanding, what Fhenix actually is, and maybe also clearing up some confusion for our listeners. But yeah, first, Guy Itzhaki, maybe you can give us a little bit of background how you met your name cousin and started in crypto.
Yeah, for sure. So my background is a little bit different than the typical crypto native folks. I've been at Intel for many years. I think somewhere around 2017 is where I started actually working on blockchain. I was leading Intel's trusted execution environment ecosystem development and did several projects with Intel SGX. One of them was actually to build a private blockchain network for a financial institute, a stock exchange. It was a permission network for lending securities. And it got me quite excited about the technology. And actually, I was, 2017, it was a very fun year to be involved in. And I got invited to tons of conferences to represent the enterprise point of view of blockchain. And in one of the panels, I met Guy Zyskind. We started chatting. And I think it was very clear after a few minutes that, we have a lot in common, specifically about the desire and the need to introduce privacy into that space. In 2017 and 2018, homomorphic encryption was just, an idea. It wasn't really mature, but SGX was, and, I worked with Guy back then about the usage of TEs within his project. But I kept on monitoring the progress around FHE and was quite excited about that. In 2020, I decided to take a leap out of that space and did a gig working on the Olympic Games. I'm a fan of sports, and when the Olympic calls, you cannot say no. Intel was a sponsor of the Olympic Games. I got the opportunity to work on the Tokyo Games and the Beijing Games. Non-blockchain related, but just very cool technological innovation in that space. We can do a podcast about that, for a couple of hours as well at some point. And then, 2022, the itch came back, and I transitioned to lead the FHE business activities at Intel. Intel is building a hardware accelerator for homomorphic encryption. It's public. It's part of a DARPA initiative. And throughout that, I basically scanned the entire market. So figure out the usage within cloud service providers, federal entities, financial institutes. And I have to say that the progress around FHE has been quite impressive. We'll get into that later on about some of the key challenges, including performance and complexity and how they're being solved. And I also met Zama, which we'll chat about them as well. And in earlier this year, I was in Israel visiting Guy Zyskind, and he told me that he's noticing the same progression with FHE. And that was really the sign for me to leave Intel and join Fhenix.
Right. Awesome. That's amazing that we have both of you here, the experts on this topic. I think, we saw a lot. Probably most people are very familiar with ZK and sort of the progress in the ZK space and in its connection to crypto and sort of the Cambrian explosion of research in that area. But I guess FHE seems more undercover still, and maybe you'll be able to shed some light into how it can be applied to crypto or why this may be a game changer. But yeah, maybe first of all, we can start off with, I guess, just the concepts of mental model of these different technologies. How do they compare and how do they work, and how is FHE sort of the maybe end state of it, is, if that is even correct to say, that's sort of how I guess I look at it. Could you kind of compare maybe for me, one of you guys, what secure multi-party computation tries to achieve, and maybe how, maybe let's start there, and then we can get into how TEs achieve it and how FHE does it.
First of all, I think at some point people in crypto will have to kind of get used to the idea that it's not either or. all of these technologies will play a part in like the end game. I do agree with the assessment that FHE is probably like the end game solution, in the sense that it will do like most of the heavy lifting and most of the important work when it comes to like encryption and private compute or secure computation, whatever way we decide to define it. But you will still need ZK regardless, even not just for scaling, but for some other things. You would still actually probably want like TEs or some form of like hardware security models, which are like a lightweight version of TEs, closer to hardware wallets in how they work. So all of these technologies will have a part to play, NPC as well. But just to give like a very, very quick overview, let's start with the problem, not with the solution. So the problem that we're actually trying to solve in blockchain is essentially what's known as secure computation. And secure computation has two branches. One of them is you want the computations to be correct and trusted. That is something that blockchains already do, right? Like you write a smart contract on Ethereum, by definition, the reason you use Ethereum is because it's a trusted platform. You know that that code is law and you're going to get a correct result. So that branch is solved and has been solved for about a decade. Then there's the other branch when you define secure computation, and that is confidentiality or privacy. Again, different people use different terms. And that is the idea that like you have a multi-user system, right? Like maybe I have my data, you have your data, Guy Itzhaki has his data. We want to run some program, some logic on top of all of our data. But for that logic, either we just don't want to share like our private data with each other for privacy reasons, or for the logic to actually make sense, we aren't able to share it. Like think about a game of poker, for example, right? In a game of poker, each one of us has our own deck of cards. If everyone sees each other's deck of cards, I mean, it's not about caring about your privacy. That's just a poker game, right? Like you can't actually do that functionality without privacy baked in. So that is really the idea of secure computation. You have multiple users sharing data. They want to be able to share their data privately, such that other participants and even the computers running the program itself can see the data. And also they want to know that the results are correct. That is a problem, right? Like the problem is how to get both correctness, which blockchain solves, and how to get privacy. And for privacy, then you have those different technologies, right? That people are getting used to at this point. So I'm actually gonna leave ZK and FHE to the end. So I'm gonna talk about two techniques that are maybe easier to grasp. One of them is trusted execution environments. These are fairly easy to understand, right? There's like a magic black box inside of your processor, inside of your computer. And basically, the assumption is that no one can break it and that no one can probe into what's going on there. So basically, if you want to do a computation privately, then all you have to do is you have to encrypt your data from the outside with some key that exists only in that black box. And then you send like your code and encrypted data to the black box, that T. The data is actually being decrypted inside, the computation is done inside, and only the output maybe gets revealed to you or to someone. So that's kind of like, using hardware, use hardware to simulate the effect of computing over private data, but there's obviously a big assumption here that no one can break that black box. I have two things to say about that. Like, as people have seen, that black box has been broken before, and even with Secret that has been an issue, and even with other systems. On the other hand, I do think people overestimate the problem with these. Like, these are an evolving technology, and many of those actual problems are going to be solved over time. But it's always going to be a simulated solution. It's not a purely cryptographic solution, and it's always going to have its problems. The upside is that it's very fast and very cheap in comparison compared to like deep cryptographic solutions. The other solution is to use something called MPC. MPC, I'm not going to that's actually probably the hardest one to explain in a way, because what happens with MPC is that the data is being split. It's kind of like a blockchain. The data is being split across like several validators or nodes in the system, and then they take like a regular program, and they basically transform it into this multi-party computation, this equivalent secure program that they can run together as an interactive protocol, where they make sure that they never reveal data to each other. Every one of them always have like an encrypted piece of the data. It's called a share of the data. But they can somehow together magically compute any program and any smart contract and obtain the output without actually bringing the data together with each other and decrypting it. So that's kind of like how MPC works. And then FHE is probably the most sophisticated technique, but it's actually easier to understand. It actually is most similar to TEAS. Really, all that happens with FHE is that everyone encrypts their data. They send it to a server or to a network of servers, but let's just say it's a single server for now. And that server just computes over that encrypted data without actually knowing what the data it computes over. And then it gets an encrypted output, and maybe that output gets decrypted, or maybe it's sent to some user. But the whole computation happens directly over encrypted data, and that's really the magic. Now, all of those technologies, they very, very directly solve the problem of secure computation. They allow multiple users to somehow encrypt their data, and then they allow one or multiple servers to compute the functionality or the smart contract or whatever over the data. And now we get to ZK. ZK actually works very differently. In ZK, you can't actually do secure computation. You can't actually combine data from multiple users and then compute over that data privately and then produce a result. You can do single user private computation. So if I have like private data, maybe it's like my age or my date of birth, and I want to prove to you that I'm over 21. So I can compute, just like a comparison, comparing my date of birth with the age 21, and then produce to you an output that says, look, I'm over 21, and also here's a proof that I didn't cheat on that computation. But if you think about the poker example again, there's no way to do that with ZK alone. It's actually not something you can do. The closest you can do with ZK, if you wanna go back to that same multi-user model, is you need to have a trusted party. You need to have someone that everyone trusts, right? Like maybe it's you, Felix, right? Well, like maybe all of us trust you more than you trust us, or that we trust each other. And so we send you our data. You run the computation in the clean, see everyone's data, and then you can send a proof to everyone that you ran whatever computation correctly, but at the end of the day, someone had to see the data, and in that case, that's you. So that's like the best you can do with ZK alone.
Okay, yeah, I think that's been a lot to unpack there. I guess you also mentioned that these technologies can partially work together, or will work together in a sense. Is that also like, could you, the computation from FHE, somehow create a proof, and like, because I guess from what I understand in FHE, you still need to like reproduce the computation to prove its correctness, I guess. Could you combine like FHE and ZK somehow to kind of prove and make it multi-user like that? Or is that another thing?
So actually to turn FHE, there's one thing I glossed over. FHE, there's an encryption key. But who has the decryption key? That is like the big question. You can't, there's a technique called multi-key FHE where you can theoretically combine multiple keys, but it's like not practical and it has other problems. So really, you need to have like one key or multiple keys, but like all the users need to, for example, encrypt their deck of cards with the same key. So again, who has the decryption key? And if someone has a decryption key, then that's like a trusted point. So what you do is you use MPC. So remember, with MPC, you can split the data. So you take the decryption key and you split that across the network, the entire network. And then that network does something called the threshold decryption. Whenever you need to decrypt the data, the network can come together without actually recombining the key. Like the key never lives in one place, but together they can decrypt, an output for a result. So you actually need MPC to turn FHE multi-user. And then for what you described, yes, you also, if you want to do verifiable FHE, if you want to do like a ZK FHE rollup, right, so which works just like a regular ZK rollup, but everything is encrypted, then you would have to go over the FHE computations and produce a ZK proof on top of that saying, hey, I ran the FHE computation correctly. That is a very active research area, but it's nowhere near practical, just putting it out there. I think we're like, maybe 5 years plus away from that. But that's going to be the end game.
Right. Yeah. I think that's like the recurring theme. It seems a little bit that like a lot of these technologies are sort of developing, like you also said, for TEs, right? Like currently, like there's still some problems, but as there's more research going in and as they're being used more in practice, they are developing. And I think a lot of that was like when I initially read about FHE, I think, for example, NewsCypher, I think was pretty early, like looking at this in 2018, 19, but then it seemed like very impractical, or there wasn't like anything there. So maybe can you, or maybe, one of you go into how FHE actually evolved and how it now became practical to do this, or is there even like still more improvements to be made, more optimization so that it's even getting even better? Like, can you maybe like kind of walk us through the history of FHE in that sense?
Yeah, for sure. So I think when I mentioned, 2017, 2018, FHE, you've started to hear about it, but when we say that it wasn't mature then, I think the challenge that you typically have with FHE is twofold. One, it's considered as very complex for developers to build on top of that. And the second one is performance. And I think even today, when we talk about FHE, there is this notion of FHE is still very, very complex and very, very slow. But like everything in life, there has been progression, and this has been constant progression throughout the years. And what we see today is actually that these problems are starting to be resolved. So let's maybe start with the developer's complexity. Because the data is encrypted, you can't really operate the way you operate on a regular program, right? There is no if and else because you don't actually see the data itself. So you need to have the application being built in a specific way. For having developers do that, there is a very limited set of people with that skill set. So what's been built in the last couple of years is actually a set of compilers that abstracts a lot of the complication from the developers. That's where I think Zama really shines, and Zama is a partner that we're working with. And with the introduction of the fhEVM, in that case, basically developers can just write smart contracts without any need to understand FHE whatsoever. They basically define or solidity based, so developers don't actually even need to understand any different new language, and they just decide which asset they want to encrypt on the blockchain, and they encrypt that part. So I think in terms of complexity, that problem specifically for the blockchain is, I can say, probably kind of resolved. The second part is computation. Now here, we talk about FHE as if it's one monolithic entity, but actually within the FHE world itself, there are different schemes. Some schemes, or you can look at them as like variant, are better for some applications and others are better for others. So you have schemes like CKKS and BGV, which are probably better when you're doing machine learning and artificial intelligence type of computation. In our case, the scheme that we are using is TFHE, and this one has something called programmable bootstrapping, which means that the noise is being cleaned every operation that's being done. Not so much important for that case, But I think that the improvement that's been happening is also on the scheme level. So the schemes are becoming more efficient, thus making the computation better. So that's part A of the solution. And the second part is clearly hardware. And as we get better hardwares, better CPUs, better GPUs, and the next couple of years also ASICs coming into play, we definitely see the path for resolution towards that. FHE, unlike MPC, is computation bound. And you can say that MPC is more of a communication bound. But with FHE, it's more computation bound. So the more hardware you throw on FHE, the better performance you get. And we're actually seeing significant progress that's happened in the last couple of years. And, I came from Intel, so I know the hardware space pretty well. And we can definitely see that in the next 12 to 18 months, there are, I say, over a dozen companies that are building dedicated hardware accelerator for FHE, which really gives us the signal that performance is going to be resolved in the next couple of years.
Awesome. Yeah. Maybe, I guess let's take that to the Fhenix, like sort of blockchain level in a sense. Like you already mentioned, you need this MPC to have the decryption key for FHE. So I assume there are some roles in the network of Fhenix, like I guess validators or maybe like different roles are. Yeah, maybe you can explain. Is this going to be like one role that the people have to run these hardware accelerated FHE hardware and also do this MPC, or are you splitting these things up? Like how is sort of the network architecture of Fhenix gonna look like? If that's already clear, or like, I guess how are you thinking about it?
I'd say it's pretty clear at this point. We put like the main building blocks that we've been building in our L2 white paper, if people want to read and go into a bit more detail. But generally speaking, like we kind of landed the right architecture with an L2, a roll-up architecture. For the same obvious reason that the roll-ups make sense in general. Like there is no reason to replicate the computation across like all validators in the network. It is enough to have like one node or a small number of nodes, like do the actual computation and sequencing and all that, and then let others just validate. And with FHE, that makes even more sense, right? Because FHE, kind of like ZK, requires like very heavy-duty cryptography that's very, very expensive. Those are, those are all hard servers. If you need to layer consensus on top of that and start to sync validators, that's gonna take too long. So anything that relates to execution is better done individually or in small groups. Anything done with validating, anyone can do it with a longer time window. We're taking the optimistic roll-up approach because, like I said, ZK FHE roll-ups are not going to be practical for quite a while. So you have the same roles that you have in a roll-up, but then you have another additional role, which is the threshold network. The threshold network will have the shared decryption key. It's going to be run by validators, and whenever the users request like a decryption or re-encryption operation, then that network, which is going to start small, but ideally eventually it's going to become like very, very large. Like that's like our long-term goal. That level is going to actually handle those. And actually we're coming up and thinking of like other like stuff that accelerates like FHE that network can actually do. Like I think at the end of the day, like most of the computations will be done via FHE, but you would be able to maybe speed up some specific bottlenecks of FHE, like with MPC on that network that actually goes beyond just like binary decryption. But that's like farther down the road.
Okay, cool. Thanks. And I guess, yeah, maybe also getting back on the first point, like sort of the developer experience point, is it fair to say like, FHE EVM and sort of ZK EVM has been sort of like, is that a similar like framing, like that like these compilers do a similar job there, or like how do you think about it? And is it only I guess you guys are focused on EVM with fhEVM, but is there also other like VMs that could be supported with FHE, or are you also working on that, or how do we have to think about that?
Yeah, I think both of us came from a very practical standpoint here, and when we started thinking about Fhenix, it was clear to us that we want to make FHE as simple as possible to onboard developers. So we made a couple of decisions. The first one was that we want to target the Ethereum community and solidity based. We don't want developers to actually need to learn a new cryptography. They don't have to be cryptographic at all to use it, and we don't want them to learn a new programming language. So the decision to go with an EVM like fhEVM like solution was the first one that was made. I want to emphasize that FHE enables you to do computation on data while it's encrypted. I know Guy Z talked about that earlier. While ZK enables you to verify data. So I don't think there are not so much similarities in what we're offering in comparison to the ZK EVM. I think that the usage of the FHE EVM is quite simple. There is an additional library that developers can utilize when they want to encrypt data on the blockchain. And once they encrypt this data using a function for decryption, that data is encrypted on-chain, and it enables to do computation on this data while it is encrypted on the blockchain. And that is, I would say, quite easy from a developer standpoint, whether it is to write a new contract or potentially to import existing smart contracts into Fhenix. The transition itself is not very complex. I think where the complexity starts to come is actually it's a mindset that needs to happen, because now you need to actually think about designing your solution with confidentiality in mind. So it's not about, okay, let's just encrypt this data and leave it there. How do I prevent others from figuring out this data through other means? So if you extract some assets from a pool, it's not enough that this asset is encrypted. You actually need to make sure that the pool itself is encrypted, because otherwise people can subtract and figure out how much you've pulled. So I think there are a lot more of a design-related questions, but in terms of the actual building blocks, it's fairly easy, and that's really where things become interesting.
So my thinking about this has evolved in the last 2 months. In the beginning, I said that I view fhEVM and ZK-EVM as very similar, but I think the more we dig into it, the more I realize they're basically incompatible. So ZK-EVM is really about writing the EVM interpreter in a way that's amenable to proving that some EVM execution ran correctly. If you're a developer, you're a developer that's running on a ZK-EVM, you just write a plain regular Solidity contract. You don't actually use a ZK. But whoever needs to design the ZK-EVM circuit, that is a very, very, very hard task to do. Whereas as guys is saying, like with FHE, like we are trying to externalize essentially library or a tool for like Solidity developers. And to your question, there's no reason it needs just be for Solidity. Like we can support everything, but like we focus on Ethereum because that's the biggest ecosystem and we're the biggest need. So it's in some ways it's closer to like libraries like SafeMath from like OpenZeppelin and like those like initial libraries where you could actually just write like faster, more secure code for your smart contracts. So think about it, you use those libraries and Solidities to write private computation code, but in a very, very simple way. Like it's as easy as using something like SafeMath. So it's really not compatible. It's more comparable to maybe like, I think Aztec's like Noir language or other DSL domain-specific languages that that other companies that are building ZK, trying to build ZK private smart contracts solutions are doing. But here is actually where FHE really shines. I mean, first of all, FHE can do stuff that ZK private compute can, because ZK, as we said, is not meant for private compute. But more importantly, because ZK is not meant for private compute, then now you have to learn a new language. You have to start thinking what computations need to happen on the client side, what computations need to happen on the smart contract, basically the backend side. Whereas with fhEVM, like with Fhenix, it's just write your smart contract in Solidity. Here's a library to do like FHE computations, and bam, that's all you need. You don't need to know or understand anything else, with the exception of what Guy said, which is not a technical component, it's a philosophical component. Like, you need to think about, you have encrypted data. If at some point you want to decrypt information or reveal information, well, maybe that leaks more than you intended to. So you need to think about that. So yeah, it's very, very different in my opinion.
Okay. So maybe to summarize how I understood this now, I guess ZKVM, you're essentially as a developer just building like a normal application still, right? You're not doing any private computation with ZKVM essentially, right? So
right,
that's one. Then domain-specific language, right? You can do like a ZK and write in another language, which obviously has the downsides of that. And then sort of Fhenix or fhEVM allows you to write the same language plus like these new use cases. So I guess, is that correct? Like on the high level, like as a summary, sort of?
Yes, 100%.
Cool. Awesome. And so then, yeah, I guess what becomes interesting, you already mentioned like sort of the poker example. What sort of like other use cases are you interested in, or like what should people get inspiration from for this, or what is already being built? Like anything really? I'm curious to hear what's happening on Fhenix already, or what you want to see actually.
Yeah, maybe I'll just start by saying that before we talk about the specific use case, I'm more of an outsider, in this space, coming from the corporate world, and I have to say that, when I look at the blockchain from the outside, it seems to me that the fact that there is basically zero confidentiality. I know some people see it as a feature, but for me, it's a significant limitation. I just feel that we're, if we want to, we're all here because we believe in blockchain and we want to see it being massively adopted. But I feel like we're in this 10 or 20% and we have this 70% of a gap that still needs to be resolved. And a key component of it is data confidentiality. I just don't see how blockchain can ever become like mainstream and very, very successful without any data confidentiality. For sure, there is like no chance that any corporates or financial institutes or government entities will use public blockchain without data confidentiality. And that is actually why we believe that this is not, FHE versus ZK versus TE, but rather, we're all here for the same goal of introducing and making the blockchain better. We have a couple of use cases that we typically talk about, but I think the belief is that data confidentiality needs to be an underlying capability. And once you make it easy to use, it will become very, very common. Similarly to the way that you operate today in the traditional world, where, everything out there is assumed to be protected. It may not be, but, it's assumed to be protected. So just putting it out there, the goal here is not so much to introduce confidentiality for it's important to protect users' confidentiality, but what we actually believe is that by enabling this new capability, it unlocks new applications that you couldn't do before. And the game of on-chain poker is a good one because, people are like figuring out some kind of solutions for on-chain gaming, but they're not really ideal. And once we introduce FHE or whatever type of solutions that's out there, you can start using it the right way. So on-chain gaming is one. I would say voting is another really clear example of how do you do voting or DAO votings without encryption. It's quite complex. Now we can actually do that with FHE. Sealed bid auctions. Guy, I'll let you talk about a few of the use cases as well.
Yes, I mean, but just to drive your first point home, like, look, I mean, we're not there yet, and we're quite far out. But at the end of the day, if like people are dreaming about the convergence of like AI and crypto, well, how are you gonna have like something like a distributed ChatGPT if everyone can see, like, if I can see your prompts and you can see my prompts, and we can actually have like models with like private data, like that's not gonna happen. So like, we have to solve that core problem, and then we can start thinking about like these really, really cool like AI/crypto revolution and many things like that. But if you want to be more grounded to what the technology can do today and what people are looking for today, then yes, on-chain gaming, voting are a couple. But I think we can't ignore the fact that there's still a lot of interest and not around DeFi and most ecosystems. Most like infrastructure and protocols ecosystem have started by bringing a large inflow of users that come for the initial DeFi application. And so the question is, what are the interesting DeFi related applications that can be done on Fhenix that cannot be done anywhere else, at least not as efficiently? So one of them relates to obviously MEV. So you mentioned that it'll be like behind the scene talks, and obviously it's the talk of the day, and Justin Drake talks a lot about it. Like FHE has really a lot of potential to like introduce solutions at the proposer, builder, separation, and block building flow in different places of the pipeline. Probably the lowest hanging fruit is around the sealed bid auctions. So auctions don't have to be done like on every block. So then FHE's efficiency is less of an issue. Like you can run an auction and choose like a sequencer for an epoch for a specified number of blocks, and that can run efficiently enough. And you can do that much more efficiently with FHE than with the other technology. And without FHE, then obviously you don't get sealed bid auctions, which are far, far superior than public auctions. Like that is a well-known game theory fact. So that is like real money on the table, like very plainly, right? Like that is a use case that shared sequencers and decentralized sequencers and pretty much all of the ecosystems are looking into right now. And that is something that's very concrete that Fhenix can solve pretty much out of the box and immediately. So that's something that we're looking into. And there's a lot of variations about that. Another use case that I'm actually very, very interested in, it's a 2 building blocks use case, but the underlying use case is actually doing something like Thorchain, like Thor swap and their lending. There's a lot of demand for doing cross-chain DeFi in a decentralized manner. Like we've seen that with Thorchain, but imagine that you can do it with Solidity, and then have all of the building blocks that people have done today, like all of the DeFi applications that people have built on the Ethereum ecosystem. Imagine you can take them, copy, paste them, and use them on an ecosystem like Fhenix, but the underlying assets are not just ERC20s, and they're not just raw Bitcoin, like they're actually native Bitcoin and native Solana, and all that, completely cross-chain, more like how Thorchain does that. And the way you can do that is because with Fhenix, like a very simple use case is you can create these micro bridges. We call them micro bridges because like you can actually have a vault inside of a contract. You can have like a private key of a Bitcoin vault encrypted inside of a smart contract, and then people can like deposit and withdraw like native Bitcoin and use that in a decentralized fashion inside of like Uniswap and other DeFi applications. So that is something that we really, really want to focus on or hopefully encourage other early developers to focus on, because we think there's a huge market there.
Right. Yeah, that seems super interesting. I guess it's like Thorchain is using some like threshold signature scheme where the validators share this key. Can Can you explain how this is different again, maybe?
Yes. So in Fhenix, like instead of having like a threshold key, what you will do, you will take like just a key or generate a key, but you generate it in FHE, so then the key is always encrypted. And you just store it in a contract state. Like you have a Bitcoin private key, you don't have to split it. You just take it as it is encrypted. You put it on a Solidity smart contract in the state, and you literally have an operation say like sign, and in the contract you do an encrypted sign, and then you only decrypt the signature. You never decrypt the key. So the key is always encrypted, and now you have a smart contract that is actually can act as a, as a wallet. The reason MPC assumption is again as well, in the sense that the ultimate FHE decryption key is split across the network, and so if you ever are able to reconstruct that key, then you can decrypt the private key in the contract. So it's not as much as it is about the better security model, although we can argue specifics why it is more secure, but that's too many details. I think the point is programmability. Like in ToeChain, like the team had to spend a lot of time like building an MPC protocol to split the key, and then build, a Uniswap kind of like a variant on top of it that uses it, and then like build a lending protocol, and each one of those takes 2 keys. But with Fhenix, once you have that building block where you can keep an encrypted key inside of a contract, like a Bitcoin encrypted key, and people can send to that address the money deposit, and then that contract can sign transactions, can basically sign Bitcoin transactions, then that's all you need from that's all the different logic that you really need. Then someone else can come in and just take like Uniswap, fork it, maybe it's Uniswap themselves, fork it, and then combine, like take those like those contracts that I told you, those like micro bridges contracts, and put them as assets into their Uniswap clone, into their other clone, into whatever. So the programmability of using now cross-chain assets becomes like completely easy and solved, and all the DeFi developers don't actually have to deal with it once that building block is there, as opposed to something like ToeChain.
Right. Yeah, super interesting. And these micro bridges, someone would have to build like something there, like some sort of, how do I have to imagine it? I guess because in this MPC world you have to build like some sort of have to have the light client, and the MPC nodes have to run it. Is this similar here, or you just need like some sort of code, more or less?
So we need to take care of the threshold network. That's like a big piece of the Fhenix protocol. That's always going to be there. But beyond that, FHE is much simpler than it's not simple. Like the math is harder actually than MPC, but running it. And by the way, that's one of the reasons I became bullish. I'm an MPC person. Like most of my research is in MPC, but like I'm more bullish about FHE because FHE simplifies from an engineering perspective and a developer perspective a lot of the stuff that MPC doesn't. So from a developer perspective, like once you have fhEVM, like the library, and you have a threshold network, and we're building those, right? It's like some of it uses like Zama's underlying libraries, but like we're building like everything on the sides and on top and improving that and all that. And once you have those, then all the developer has to do is literally take a Solidity contract that will have an API to generate a key, an encrypted key in the contract, right? Like like through the library, they will be able to sign transactions within the contract, within the Solidity contract from the library, without ever decrypting the underlying private key, and they won't have to worry about pretty much anything else. So I'm not sure if that answers the question, but it's like really, once you have the building blocks, it's all there and simplified.
Yeah, and I would say this is really the goal, which is to build a very strong set of capabilities that then enables developers to take and build the likes of ToeChain and other solutions without having the need to spend a year or a year and a half to build your own protocol with a lot of cryptographic complexities, because it's all pretty much baked in the underlying Fhenix infrastructure.
Makes sense. Thanks so much for expanding there. I think we talked a lot about, I think, one question that I wanted to address, and we also talked behind the scenes already before a little bit about it, but I guess, privacy and blockchain, we have like this sort of relationship where on the one hand you want it, obviously, like, so institutions can use it, but then you have this other side essentially where like having private transactions and private things can also mean that not even the government or someone can look into it, and maybe you have like compliance issues, right? So like one big example there was like Tornado Cash and sort of how that impacted the Ethereum like landscape through, for example, also flashbots, but in many ways. I guess the way I understand it, you can build like these applications on FHE. So I was wondering, what's your approach to like sort of compliance and confidentiality? Is there any thoughts you guys have, or how are you building towards, I guess, making it possible for also governments to be involved in this sort of technology?
Yeah, that question came a lot, in our early days, and people, they heard about Tornado Cash, and in Tornado Cash, what happened was that the identity of the users was actually masked, which is different than what we are offering with Fhenix. At Fhenix, it is the content of the transaction that is encrypted, but actually we're not masking the identity of the users who are doing the transaction. And this is a significant difference. So if the government has an issue, they would be able to identify who the person is, similar to other blockchains. That's no different. But the content of the transaction itself is encrypted. Now, there is definitely interest. We've heard it from multiple entities about applications such as dark pools, etc. And we believe that they can be resolved in a compliant manner. So have an identity, which is decentralized identity encrypted on chain, that goes through a compliance process and then being used in a comparison with a pool. So that's really it's a significant difference. There is no plan here to offer capabilities similar to Tornado Cash on top of Fhenix.
I'm gonna give a slightly different version, if I may. This is not the use case that we're focused on, and this is not something that we're focused on out of the box. But like you can, even as it currently stands, you can use FHE to build anonymity as well. Like there are ways to do it, and if people and developers want to do it, they can do it, even if we're not gonna be the ones focusing on. But it is possible to build it on top of Fhenix if people choose. And the other angle is that I do think that, like, even if people choose to build anonymity using FHE, which is more akin to Tornado Cash, but it works differently, but still gives similar results. The benefit compared to Tornado Cash is that FHE, like MPC, like trusted execution environments, they are completely programmable. So if we go back to this idea that ZK has a lot of limitations at the end of the day when you're trying to do like private computations, especially in a multi-user environment, FHE doesn't suffer from that drawback. So you could technically, like, developers can come in and program in like a completely privacy-preserving USDC variant that also has like selective disclosures, like on an aggregate level, like maybe there's like a fraud and an encrypted fraud detection algorithm running inside a smart contract that only if there's like a really, really suspicious alert with a more than 90% probability, then it sends that to some authorized third party. So like you can actually do all of those things with Fhenix. I don't know that we will be focusing around it, and definitely I think, but I am kind of curious what's going to happen when developers come in and actually try to do these things, because I think then the crypto ecosystem will have to face a very difficult question, like are we willing as an ecosystem to have a system like that, or does that completely go against the crypto ethos? I don't think I want to be the one to answer that. I hope other people will put themselves in the position to answer that. But it's absolutely technically possible to do with FHE.
Right. I think, it makes perfect sense. I do think that question is being like sort of shifted around, because I guess in the end, no one really wants to deal with that, or can, even maybe because it's like pretty hard to be in touch with all governments and like sort of focus on that, because in the end you're trying to build technology. So I think that makes a lot of sense. I think we covered a lot of ground, running close to an hour. I wanted to like kind of end it by talking a bit about the sort of roadmap of Fhenix, and where you guys are at in terms of the launch of the L2 or testnet. Please let me know. Like, we're recording this here on January 8th, so what's the plan for the next few months?
So we have our DevNet already up and running. It's a limited access DevNet. It's been up and running in the last couple of months. Testnet is coming in Q1, and then goal for mainnet is early 2025. I will say that people are definitely encouraged to come and sign for the testnet once it's available. We're going to be in East Denver. Looking forward to seeing everybody. We're doing an encryption day during that period, so it's going to be a very interesting event. We have a great line of speakers all over, and it's going to focus not just about FHE, so MPC, ZK, trusted execution environment. So again, encouraging people to join to that. But testnet Q1, and then goal for mainnet is early 2025.
Awesome. Sounds like a realistic timeline, maybe for a change. It's not like super close, so I wish you the best to like be able to hit those milestones. And definitely, if you guys go into Denver that are listening, try to check out the Encryption Day. I think that's it from my end. Thanks so much, Guy, for coming on. It's a really insightful episode. I hope people picked up something on FHE, and we'll link to the website and some other material in the show notes.
Thank you very much.
Thanks a lot, Felix.